Huh. How about now? Can everybody hear me?
Yeah, we can hear you.
Alright, I got some thumbs up here in Zoom. Alright, hello. So, hi. My name is Ben West. I am the assistant here at the Edelman Planetarium, and I will be manning some telescopes here and running the bulk of the stream. Joining me is also Amy Barracqua, who's really only going to be visible through Zoom here, but she'll be sitting in the chat as well as, actually, I'm not sure if, I guess if you speak through Zoom, it will probably catch it.
I think it should,
Yeah.
before. So, hi everybody.
You're also muted through Zoom.
All right. Good evening, everybody. Thanks for joining us. I'm the director of the planetarium, and I'm going to be hanging out throughout the whole show, monitoring the chat on the live streams and also on Zoom. So if you have questions about what you're seeing or just in astronomy in general, please feel free to type in those questions, and we'll do our best to answer everything that we've got. We've got some pretty clear skies tonight, so we're looking forward to being able to show you some views of Venus and Mars, and also maybe the moon. So I'll turn it back over to you, Ben.
All right, thank you, Amy. Yeah, as Amy said, we have some, hopefully that was heard through YouTube and Facebook here. We have some partly cloudy skies, but hopefully we'll be able to get some good views of Mars, Venus, and the moon. So I'm actually going to switch us on over to a view through our telescope, which is currently actually pointed at Venus and Mars. And so you can actually see Venus here down below, down here. And up here we actually also have Mars. Now, unfortunately, in order to see them kind of well, we're going to have to stay pretty zoomed out, but they are actually pretty close. And they're actually about as close together in the sky as the moon is wide in our sky. And actually, our view of the telescope is actually currently upside down from what it really is. Let me fix that real quick here. There we go. So, I've flipped the view to be more appropriate for how we would actually be seeing it if the telescope didn't flip things. So we can see here the incredibly bright Venus. Venus is actually so bright that you can actually see it during the day if you know right where to look in the sky. Of course, you have to be careful not to, see the sun or look at the sun during the day, so you want to block out the sun with your hand. But if you do know where to look in the sky, you actually can see Venus as a faint pinprick of light up in the sky. Mars is quite a bit dimmer, so you can't actually see that one during the day. In fact, it's very hard to see right now shortly after sunset. It'll become a bit easier to see in a little bit, assuming the big clouds right in the way don't block our view. So I'm actually going to flip us over to a view through a camera pointing out in roughly this direction. So right now we can see Venus down here, and we actually can't really see, let's see if we can zoom in there at all. Yeah, we can't really see, oh, there we go. Very faintly, we could see Mars right down there below it. But you can see that Venus is considerably brighter than Mars. Also, we're getting a bit of a... Let's see if I can get that any more in focus.
So while Ben's adjusting the focus, feel free, if you are joining us on Zoom, you can go ahead and unmute yourself if you'd like to ask questions. Otherwise, please type in your questions into the chat or on Facebook or YouTube, wherever you're watching today, and we'll be happy to answer those while we deal with a couple small technical issues.
Yeah, sorry. Alright, so it does seem that actually wasn't focused, but we are currently looking through a cloud, a very thin cloud. And so what ends up happening there is when we're looking through this cloud, it ends up blurring our view of everything a bit, and that can make it a bit hard to tell whether or not something is in focus. But I'm going to go ahead and move us on over to the moon, which you should be able to see a little bit better through the telescope. And while I'm doing that, no, that was pretty quick. All right, I'll just switch us on over to the moon then. So we are back over to the moon here. And so currently we are in what's called the waxing crescent phase of the moon, where new moon was a little less than a week ago. I guess, what, 3 or 4 days ago? The 10th. So yeah, 3 days ago. And so currently we have just a little very thin crescent of the moon here, which is going to slowly grow over the next few days until in about 4-ish days it should reach the first quarter phase moon, when the entire right half here will be completely lit up. And so currently what we're looking at is the daytime side of the moon, the side that is being lit up by the sun, as well as mostly actually the nighttime side of the moon. And we're also looking through a lot of clouds, which is why we have some haze. But while we're... oh, that's going to completely go away. Alright. That's okay. I'll see what we can capture here with a picture. Maybe we can get something through the clouds. Oh boy. There we go. Alright, so I'm taking a picture through the clouds so we can still see a bit, but it's a bit harder to see stuff. Let's try to make that a little bit better. So, yeah, that's still pretty difficult. But from what we can see here looking at the moon, we can clearly see a lot of craters on the surface of the moon, and this is actually a pretty good time of the moon, of the lunar cycle there, of the phase, or a good phase rather. Sorry, so I should have said that. A good phase to be seeing some of these craters. So looking along the terminator, which is not a reference to an Arnold Schwarzenegger film, but rather this line right between daytime and nighttime in the moon. Looking along the terminator, we can actually see all of these craters. So these circular pits dug out of the moon when an object collided with the surface of the moon, knocking out a chunk of the moon and leaving behind, well, this crater, this kind of hole in the surface. And we can also see craters within craters. So you can have craters within craters, you can have craters right next to craters. The surface of the moon is very, very, very heavily cratered. And when we're looking right along the terminator here, all of these areas are currently in, they're just about at sunrise. And so if you were to be standing like right on the crater rim here, a lot of the area inside of the crater wouldn't actually be able to see the sun, because the sun isn't quite high enough in the sky. And so we can see a lot of these darker areas that are still in shadows, where we're seeing the shadow of the crater rim basically being cast over the edge there. And just above it we can of course see the lunar surface, the surface of the moon there, being lit up by the sun, because there you're actually able to see the sun. So we can see all these shadows inside the craters, which can also give us a bit of an idea of some of the depth of some of these craters. That's actually really, you can see that pretty well here. So you can see the circular crater rim, and about half of that crater is lit up, this half here, and about half is not. So, can we, no, Venus is pretty blocked, isn't it? Well, we can try to get another, what was that? Yeah, Mars is not going to be visible. Trying to see if we can get a picture through the clouds. It just makes everything hazy, but it still might be doable. Getting there. Almost there.
You could also switch to the camera view.
We could switch to the camera view, yeah.
So that they can at least see the clouds and
That's a fair point.
Wait for Venus to pop back out from that cloud.
Yep.
We never
So-
have any good luck here in New Jersey. The clouds are always exactly where the astronomical event is, whether it's a conjunction
Always.
or the solar eclipse
Yeah.
or...
Right above our heads is like,
It's perfectly clear.
it's not perfectly clear. There's still some clouds, but we could definitely see a lot more if it was darker anyway. If we were to wait a little while, which is always how it goes. It's never clear where you want to see stuff.
So if you're interested in how we actually do this while we're waiting for the clouds to clear out, we actually have two different cameras connected to different pieces of equipment. One is connected directly to one of our 6-inch telescopes, and that's what we're using to show you the close-up views of the moon and also of Venus and Mars. But then we have a camera with just a standard zoom lens that can do wide angle and very zoomed in. And we switch back and forth between those two views when we're doing our live streams like this, because the camera with just your standard lens can give you the wider view to give you a sense of the constellations, or in this case the cloud cover exactly where you need it to where you don't want it to be, and then the telescope to really give you those zoomed in views. So Venus is now visible, Ben.
I
and
see
Mars
that.
should be too.
Yeah.
So
So
hopefully
yeah,
we'll
now
be
we
able
can
to
see
switch over.
Venus right down there, and I'm currently trying to get this other camera.
So right now we have it set to the camera with just a standard zoom lens, so you can see that wide angle, tiny pinpoint of light. That's Venus. Mars is not exactly visible
go.
through that same view.
It actually might be.
It's very, very faint. Hopefully it'll become a little bit easier to spot as the skies get a bit darker.
Yeah,
but
actually we can see it.
you can see them
It's this
through the
faint thing down
telescope,
there.
though. Yep. So
Well, this is actually through your camera, Amy.
Oh, do you have
This is
mine
through the wide
zoomed
field,
in?
yeah. So we can
Okay.
actually see it as this faint dot down there.
Yeah.
But if I switch on over to the oh, whoops. No, I was showing it. All right. If we switch back over to the telescope view, now we can see it a bit better. So up here we have the faint dot of Mars, and down there we have Venus. And if I zoom in, I do wonder if I can get a... it's going to show the moon for a little bit. Let's see how clear of a shot we can get of Venus, if any. Nope, that's not going to look great at all.
So when you're looking at the live views through either the camera or the telescope, you'll notice that the objects flicker quite a bit. This is actually due to our atmosphere. It's not the planets or the moon or even the stars that are flickering. The light is moving through our atmosphere, and the more turbulent the atmosphere is, the more of this flickering called scintillation that you see. So you can see quite a bit of that flickering. Mars seems to be disappearing from time to time. It's flickering so much, and that's just due to our own atmosphere. So if you can adjust the view a little bit, you just lost Mars.
No, I can still see Mars.
It's below the view.
It was on your camera at the time.
Oh.
Because I was trying to get the telescope lined up. So right now we're looking at Mars, which has a lot of that scintillation or twinkling occurring to it right now. So we can see it bouncing around a whole lot. It also has some distortion from the optics, which are causing the colors to smear out a little bit. And we can also see a whole bunch of noise from the camera. Let's see if I can quite get that focused any better. Nope, that was already pretty well in focus. So yeah, we can see it moving around a whole lot. And the same is also occurring with Venus. And so we can see them moving around a lot, and it's definitely not aided by the fact that it's pretty windy here. Or not pretty windy, it's not super windy, but it's a little windy. As I say that, I'm getting a bit more of a gust of wind. And so the windier it is, the more the air is moving around, the more turbulent that air is going to be, the more scintillation we see. And so...
It also shakes the cameras a little bit.
It also shakes,
too.
yeah. It's going to shake the camera, it's going to shake the telescope. So on top of the air bouncing around, you also have a camera bouncing around, which is definitely more pronounced when you're zoomed in with the telescope there. It's a bit less pronounced when you're just looking through a camera on the tripod. So, no, it's still not quite dark enough to see much. Oh, actually, there is a cloud directly above our heads now.
Yep.
So that's out of the equation. Alright, well. So, one thing you could do here is keep in mind how far apart Mars and Venus here are. And so just keep that in mind for just a second. Actually, let's see if we can just get a picture with that to show it. And then I'm going to switch us over to... That's not good. Oh, there we go. Alright, and I'm going to switch us on over to looking at the moon, and you'll see that the width here, or rather, I'm sorry, the distance between Venus and Mars, so again, Venus and Mars, which you can actually see here is pretty distinctly orangish red, the distance between them there is about the same as the width of the moon right now, just about. So I can blink between them, and it's pretty close. Maybe I can move that up a bit. So they're just a little bit further apart than the moon is wide. Although actually now we have a pretty clear shot of Venus.
Yeah, you should easily.
Yeah. Let's see here.
So we're trying to change the view of our camera a little bit, setting it closer to its widest, which is about 18 millimeters, because we'd like to see if we can get both our thin crescent moon and Venus together, and it looks like...
Which I just did. Very much free-handed that, so I'm glad it's still somewhat level. But yeah, so as the night goes on here, these are both going to be moving kind of in that direction downward-ish, very roughly. But given the exposure here of the camera in the mode we have it in, the moon is very blown out, but we can see Venus. If I was to go into taking a picture here, not sure what settings I'll need for that, but we might be able to get the crescent a bit better. There we go. Yeah, so you can see the...
just barely see the bright dot of Venus.
So you can
Mars
barely see the bright dot of
visible at
Venus
all.
down there, yeah. Mars is definitely not visible, but you can definitely see the crescent there of the moon. Oh, something else we can also see, if you have a good eye, is Earthshine bouncing off the moon there. So I'm not sure how well it shows up on the stream, but we see the very bright daytime side of the moon here, the side that's being lit up, of course, by the sun, and the moon basically sees the opposite phase for the Earth. So whereas right now we have a waxing crescent phase of the moon has a waning gibbous phase of the Earth, which is to say that instead of there being a little sliver that's lit up, there's a little sliver that isn't lit up. So the moon right now is seeing a very, very, very bright Earth.
Big
So all
Earth.
what?
Bright big Earth.
Bright big Earth. What did I say?
No, I just added big.
Oh yeah. I'm sorry. I thought I said something wrong. So looking at the moon, if you were standing somewhere here on the surface of the moon and you looked up in the sky, even if you couldn't see the sun, you could still see the Earth, much like how sometimes during the night or sometimes during the day, depending on where the moon is, we can see the moon, say, well, actually, with what I was saying, sometimes we can see the moon at night. Sorry for being confusing. So sometimes we can see the moon at night, and likewise, the moon, well, because of how the moon is, the side of the moon that's always facing toward the Earth can always see the Earth. And so if you're on the moon and you can see the Earth might be lit up, and if it's lit up, you're getting light from the Earth, right? So just like how, say, during the full moon, it can be pretty bright outside here on Earth, on the moon, if it can see a pretty well lit up Earth, it's also going to be kind of bright. So you can see a whole lot of light from Earth, and that light from Earth ends up bouncing again off the surface of the moon and then comes back to us. And so we can very, very faintly, maybe I can take another picture here that's like twice as bright, maybe that'll help. If it doesn't blow out. Yeah, we can see the disk of the moon still partially lit up by the Earth. Now, because of some thin hazy clouds, we can't see any detail there, but you would actually be able to see some brighter and darker patches on the moon. The darker patches being called Maria, and they're areas that were at one point basically filled up with a volcanic sea left over from lava having come up to the surface after an impact.
Are we able to see Venus's phases? Can you adjust the exposure enough to be able to see what phase Venus is in?
If I take off the... No.
Okay.
No, I don't think we're going to be able to... I mean, if I took off the focal reducer, maybe?
Why would the focal reducer adjust the phase?
Because it seems to also be adding in some aberration. That's just ruining everything. If I put it to the center of the... Well, also that would help us get greater magnification. It's currently reducing it by like 0.63 or something. Somebody asked about, by the way, just on that note, someone asked what zoom this is. We don't really tend to measure telescopes in terms of magnification or in terms of zoom. We might think of it more in this case, we might be thinking of it more in terms of the field of view that we can see. So a very, very, very handy measurement tool in the sky for measuring field of view is actually the moon. The moon is about 1/2 of a degree wide. So if you were to imagine, drawing a large circle around the sky, and you were to cut it up into, well, 360 tick marks, right? 360 degrees, that the moon would be about 1/2 a degree wide in the sky. And so typically, with our this camera here on this telescope, in this, whoops, let me switch our view over. Typically in the vertical axis here, so from this direction, we can actually fit about one moon width, about 1/2 degree. We have a focal reducer on it, which basically just is widening our field of view a bit. So it's about whatever 1 over... Yeah, it's about 0.8 degrees, roughly, right now. Thereabouts, maybe closer to a degree field of view. So I am going to switch us back over to the... Unless we don't want to do that, because it's going to take a little while to refocus, and I'll probably mess up the alignment. Also, we can't even see Venus anymore.
Venus just went behind a huge cloud.
Yeah, that's a completely moot point. Never mind then. Alright. Well, that's a shame.
So, I had been hoping that we'd be able to show what phase Venus is in, because Venus, like the moon, actually does show us phases. Galileo was the first person to notice that when he pointed his telescope to Venus about 400 years ago. We never can see the full phase of Venus because Venus is closer to the sun than we are. But right now it's at about its maximum phase, which is a little bit more than 50% of the planet illuminated by the sun. So I was hoping we'd be able to show that, but there is a very large cloud right in our west-northwestern horizon where Venus
completely blocking that very rudely.
So So we might have seen as much of the conjunction as we were going to be able to view this evening, but we'll stay here for the next 30 minutes until Venus and Mars set below the horizon, and hope that in that time this cloud moves away so that we can head back and show you those two planets. We can't see a whole lot of detail on the planets right now, partially due to the scintillation, that twinkling that we talked about earlier, but also Mars in particular is pretty far away from Earth in its orbit right now, so we don't see very much brightness or detail in any of its features. And Venus, we're not actually looking at any of its surface when we're looking at the planet, we're just looking at its cloud top, so there isn't a whole lot of detail on that particular planet that we would be able to view. We're just seeing the bright clouds and the changing phases over time. So hopefully we'll be able to head back to those objects a little later, but as it gets darker, we'll be able to point out a few other things in our sky as well. So
well, if this haze goes away, it's actually pretty much completely covering the sky at this point.
Yeah.
Unfortunately, except for over there where there's nothing because there's Philly. Something else actually which would also get in the way of us trying to see a lot of detail, any detail really, on the surface of Mars in particular, is that even if there were no clouds, it's gotten rather close to the horizon, and so that scintillation gets worse the lower in the sky something gets, because you're looking through more and more air. And so one thing that's making the scintillation particularly bad is we're looking through it pretty close to the horizon, right? So you're looking through a whole lot of air to see it, and the more air you're looking through, the more light, or the more distance through air that light has to pass through, right? The more chances to run into turbulence it gets, and the less you're able to see. So, sorry, I cut you off, I believe.
That's okay, I don't know what I was going to say anymore.
I am sorry. Darn, I don't think... Well, unless we want to see bright blinking stars known as planes. Oh, what is that one up there? That's...
Well, is that one of the summer triangle stars?
I don't think so. Maybe. I don't know, I can't see the other stars to
Other,
reference.
yeah, right, I can't see the other two.
Hold on, let me use the handy tool known as Stellarium. Looking southwest-ish. Spica. Oh wait, no, that's Arcturus. Spica's lower, I think. Or, yeah.
Higher than I'm expecting it to be right
You
now.
know, that's Arcturus up there. Oh, I should probably point the camera there. That'd be very helpful, right? So we're not just talking into the... Hold on. Let's see if the camera can even pick that up. So we have the moon, and then we're going to see if maybe, just maybe... Probably not.
I don't think so. I think that it's too far away that for you to have both the moon and...
Well, I'm not trying to get both in. I'm just trying to see something.
Yeah, it's so faint. I think there's also a thin cloud over it, too.
Yeah, that's not happening. Alright, let's put that back in the moon. That is a shame. Can't say I didn't try. Alright. So, yeah, there's Arcturus there, and we'll see if something else pops up. The moon, at least, is visible. That's great.
Well, I'm wondering if the Big Dipper is visible, because you could show Alcor and Mizar, but I'm not seeing anything. It looks like there's quite a bit of cloud coverage now, pretty much everywhere.
Yeah, I was also looking there. There's a big old cloud right in the direction of the Big Dipper. Well, actually, no, then, yeah, there's just a thin haze over everything at this point.
Yeah.
You can even see the clouds moving here over the moon.
I'm not sure yet if the haze that we're seeing, sometimes here in New Jersey, the haze that we're getting is actually smoke in the atmosphere from the wildfires out west. I know that at this point it's at least reached the central states of the U.S., but I'm not sure if the smoke is affecting our view here in New Jersey yet. But as the summer goes on and the wildfire season continues, I think.
I remember last year, I think, when it got really hazy and I couldn't see like anything for a little while. That was pretty crazy.
Can really affect our ability to view things, because that smoke particulate gets very high up into the atmosphere and makes it difficult to see fainter objects. It does make for some beautiful sunsets, though. Makes them appear quite a bit redder than usual.
Checking right now, I don't think the smoke has reached over here. Yeah, no, it's not the smoke, it's just clouds.
It's just clouds.
Yeah, it's just in the central U.S.
So again, I'm just going to encourage people to type or ask questions for us while we sit and wait and hope that some of these clouds depart so that we can see something more than just the moon. The moon, because it's so bright, is usually visible even through very thin clouds, so we do still have our cameras and telescopes pointed at it, but it's just about the only thing that we can get a good view of at the moment. So it does not have to be related to the Venus or Mars conjunction or the moon. It could just be any pressing astronomy question that you've been holding on to.
Yeah, any questions
really
at all,
answered.
go for it.
Somebody has typed into our Zoom chat, is tonight the closest that the two planets will be? This will be the last night that they will be this close. I think that the conjunction it started on the 11th. Yesterday they got just a little bit closer. Today they are, I think, the conjunction 2 degrees farther apart than they were yesterday. But they're a little bit easier to view together because Mars is now down below Venus, where
Amy, I'm gonna cut you off and ask you to repeat that, because I went into the I just went to go check the chat in Facebook, and it started to play the sound, which is playing through the stream through my computer. So it started to become a feedback loop of a cacophony of Amy voices. So you might want to back that up like a minute and just start again. I'm so sorry. Sorry for everybody else who just heard the increasing number of overlapping voices there.
All right. So what I was trying to say was that the conjunction happens pretty slowly. All conjunctions do. It started on the 11th, so Sunday. Yesterday, the 12th, they were pretty close together. Today, they aren't quite as close by, I think, 0.02 of a degree farther apart than they were yesterday. But the positioning of them is actually slightly better for looking at them through a telescope and even finding them naked eye, because Mars is now just below Venus. So when you're looking at the two objects in the nighttime sky, they're a little bit easier to spot. At least they were before the cloud rolled in.
Yeah.
Thankfully, yesterday, even though I think it was just a tiny bit closer than it was, or than they are today. Yesterday, of course, we had those thunderstorms rolling in, so we wouldn't have been able to view it yesterday here from New Jersey either. So
I think we might be pretty well out of luck here. I don't think we're going to be seeing much more tonight than the moon. So somebody asked here in the chat on Facebook if we are open now. Unfortunately, so we're still, right now we're closed due to some ongoing maintenance and repairs, much needed maintenance at that. And so we hope to be reopening in September, I believe, right?
Yes.
Yeah.
We are preliminarily setting our schedule to start Friday, September 3rd. We're just waiting for some approval from the administration here at Rowan. But when we do reopen, we are going to be reopening with 3 brand new shows. So if you visited the planetarium before, I definitely encourage you to come on back because we have so much new to show you. If you've never been, well, then there's no better time to come than this fall when we reopen with all those brand new shows. Yeah. So just looking at the cloud coverage now, it just looks like it's getting worse. There's really not a whole lot to see. So Ben and I will stay on for another 5 or 10 minutes to give you chances to ask us any other questions that you might have. But unfortunately, I think that we're not going to be getting any more views from our telescopes. So I'll just encourage you to ask any questions that you've got. One person here typed in the chat, are we going to be doing laser shows? Yes, the laser shows that we are planning are Laser Floyd the Wall and Laser Michael Jackson when we reopen. October will also bring back Laser Halloween too. So we're looking forward to having that all back. We recently upgraded our whole sound system. We've got a brand new set of speakers and a brand new subwoofer. So the music is going to feel even more immersive and has a much higher quality than it did before. So we're excited to share that with you too.
We may actually be in luck. We might actually be able to see. We can very barely see them. But I'm going to try to see if we can see some stars here. Maybe not. Alright. Guess what we've got? We have some stars. It cleared up right around Mizar and Alcor.
Oh, is that what you're pointing to?
Yeah. Oh
All
no,
right.
they're gone. Very good. I looked up and I'm like, hey! So, I have us pointed right now to Don't hit telescopes. They shake. So currently we're pointing to... Hopefully I didn't bump the mute on my microphone. I did not. We are currently pointing right now to a double, a binary, and a double binary. So a double star is where we see two stars close together in the sky. And if I zoom out, you can see kind of a rough approximation of that. So we have a star here called Mizar, and we have one called Alcor. And when we're looking here at these stars, let's see if we can get a picture real quick before they get ruined by clouds. Maybe a bit longer. There we go. So when we're looking at these stars here, there's Mizar and there's Alcor. And they're very close together in the sky. They're so close together that if your eyesight isn't really great, they might blur together. And so we call them a double star. And when we look at them, we can actually see that Mizar here actually appears to itself have two stars, and we call that a binary star, where we have two stars actually physically very close together orbiting around each other. Except that I've actually completely lied. I'm trying to get them in view here a bit better. There we go. So as it turns out, Mizar is actually not a binary star where we have two stars closely orbiting each other. It actually has one pair of stars here and another pair of stars here. And each of these pairs is made of two stars that are incredibly close together, so close that they blur together in most telescopes. Nearly all telescopes, in fact. You can only really tell them apart using other means. But we actually have here a pair of stars orbiting a pair of stars, and we call that a double binary. And Alcor, as it turns out, is actually another one of those binary stars, so it has two stars orbiting around each other. And so we have a double of Mizar and Alcor, made up of a binary of Alcor and a double binary of Mizar. And these two stars, we're probably not quite going to be able to tell it. Maybe. Probably not with the wide field, so I won't try. These two stars here, rather Mizar in particular actually, it makes up part of the handle of the Big Dipper, or the tail of the Big Bear, Ursa Major. Mizar is the star in the middle of the three stars that make up that tail or handle, and Alcor is just above it. And, yeah, that's really not going to be all that visible through the wide field, I don't believe. We could try. I think the Big Dipper is like the only thing that's visible now. There's like a slight clearing in the haze, like right in that direction, but there's like nothing else to see there.
Not even sure that I can see where the Big Dipper is.
It's up. It's up there. It's very hard to see.
There's so much cloud coverage that I can't see it.
There is. Let's see if I can get a picture of it. I'm going right now through our wide field, and it's probably not even pointed in the right direction, actually. I'm just kind of trying. Oh, that's not in focus. Alright, I don't know what happened there. I must have bumped it. Whoops.
You zoomed in and out. That's what you just
Oh, I did. No. No. Let's just see what happens. Can I... Did that worsen it or make it better? Very much worsened it. Alright. Let's try that again. Oh. There we go. Alright, I don't have any idea what I'm pointing at right now.
There's 3 stars there, though.
There are 3 stars. What are we pointed at? I don't know. We have, oh, is that, is this a tight crop of the handle? No, that doesn't look like Mizar. I have no idea what we're pointed at. I'm gonna take off the headset for a second. Alright, we're getting there. We are looking at the Big Dipper. Focus is not great, because I've ruined that. That's better. It's not great. Yeah, so there's a cloud now blocking the Big Dipper. That's a shame. Can't say I didn't try. Alright. Just go all the way out. Yeah, but we are currently looking at the Big Dipper. You can barely see it through some clouds. You have the handle or the tail of the Big Bear, or some major. So we have 1 star, 2nd star, 3rd star, and then we have kind of the cup of the Big Dipper. It's very hard to see. But if we have the 3 stars here of the handle of the Big Dipper, Mizar is that one right there. Unfortunately, that's pretty much invisible, because there is a big old cloud in the way. It's hard to tell because I keep on looking at a bright laptop screen.
Right.
That keeps on blinding me, but I think that might be... Yeah, we can't even see Arcturus, and that one's pretty bright. Or
Yeah.
Vega. Yeah, I don't see anything. Yeah.
Yeah, the only bright points that we're seeing now are just the airplanes flying out of Philadelphia Airport.
Yeah.
So, I think that Venus and Mars will be setting in about 4 or 5 minutes, right around 10 o'clock. They will no longer be above the horizon. So even if these clouds clear out, sadly, we've gotten all of the views of that conjunction that we're going to get. We are going to stay on for just a couple more minutes, again, for you to ask any astronomy or planetarium related questions that you might have.
and we will be ending this stream right at 10 o'clock. So feel free to ask any questions. We're here to answer them for you. I will mention that on Zoom we had a great comment about the double binary, and I mentioned that there's another binary star that we enjoy showing in the summertime. It's known as Alberio, and it's in the constellation of Cygnus the Swan. This is one of my favorite ones to show because the two stars that are orbiting around each other are also two different colors, and you can clearly see the difference between the two. One appears a really bright blue and the other is kind of a golden yellow like the sun. So that star color actually gives us an indication of just how hot the two different stars are. Hot stars are really blue, where cold stars are actually red. Yellow stars like our sun, or the one that we see in Alberio, are somewhere in the middle. So that one's always a fun one to see in the summertime, but sadly, where it should be somewhere right directly above my head, it is covered by clouds.
So I've currently got the wide field camera here pointed at the Big Dipper, in theory, but as we can see there are clouds passing in front of it, and I have it currently set to a sort of stretched mode with the light, which is why we have a whole bunch of vignetting at the corners, so that maybe, just maybe, it'll catch a bit of light from the stars that we can kind of see, but unfortunately I don't think that's the case. But looking at the moon, it's actually pretty clear at the moon now. Ooh, let me switch over to the moon. This looks good. This looks good. All right. Awesome. So, I got Earthshine. Awesome. All right. So I mentioned before the Earthshine looking at the moon here. So what we're currently looking at is, again, the moon, and I have it blown way out for the image here so that the bright side is completely way oversaturated. But you can see a bit of the... Maybe this will make it slightly better? Not really. That doesn't really make it much better, does it? Yeah, not really. So we can see, though, the darker areas on the surface of the moon here, called Maria, which means seas or lakes. A long time ago, people looking up at the moon thought those might have been seas or lakes on the moon. Turns out they were not. They were areas that were craters. They got filled up with lava, and then that lava hardened. So these are volcanic plains, which makes the different makeup of the ground there, makes it rather dark. And but they are, you can see maybe roughly a bit kind of circular-ish, because those are left over from craters. Maybe this is a better example right there. And so those Maria are actually incredibly they're very, very, very smooth, which makes them very ideal places for, say, landing spacecraft. So most of the Apollo missions, I believe all of them, landed on those Maria. And so then if I considerably reduce the exposure time here of the moon, and we can start to see some of that nice crescent. Now that we're getting a bit closer to the horizon, it's starting to look considerably worse, but we can definitely make out those craters pretty well along the terminator here. As well as some Maria on this side, and crater right there, with Maria, of course, inside. It's actually a pretty good example here. We have craters which, of course, did not fill up with lava, and you can see kind of the, well, actually you can't see it all that well. Another pretty cool thing you can see actually looking at this crater, although it's very hard to tell, right at the center there's a little bump. And basically what happened there is when something hit the crater, sort of like how, if you've ever seen like a graphic or a video of a ripple in water, something dripping into water causing a ripple to form, when the water goes down it can come right back up in the center. that actually has basically happened here with the crater. So once something hit the moon there, a bit of the surface sprung back up right in the center, forming a little peak right in the center. And I don't believe we can quite see that. Yeah, it's pretty hard to tell with most of the other spots here on the surface. Oh, there's another crater. We can see it right there. So where did that lava come from, somebody asked. That lava came from beneath the surface. So something hit the moon so hard that it punctured through the surface of the moon, allowing magma beneath the surface to rise up to the top. Bear in mind, most of these older craters that formed Maria are very, 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 very old. And so at the time, the moon's surface, or rather its crust, the very thin part that at the time made up its surface, it was very, very, very thin. Now it's much, much, much thicker. The moon has cooled down a lot, but we're talking way earlier on in the moon's history. The surface of the moon there, the crust was incredibly thin, and so it was a bit easier for, maybe not incredibly thin, but a bit easier for larger asteroids or other things impacting the surface of the moon to puncture through and allow some magma to come up. It is a solid rock, pretty much now, but a long time ago there was a bit more liquid inside, although it actually might be, there might be a bit of, no, I think it's pretty much, it's cooled all the way through, right? Yeah. But a long time ago there was a point soon after the moon's formation when that wasn't quite the case, and there was some magma to flow up. So these are very, very, very old features. Unlike the surface of the Earth, which is geologically active, there's stuff actively changing, the surface of the moon is, well, the moon in general is not geologically active, so anything that happens on the moon is pretty much there to stay. So if something were to hit the surface of the Earth, hit hard enough to have allow magma to come up, to allow lava to come up to the surface, eventually that geological feature would go away. It would be whittled away by erosion or by the moving of tectonic plates or any of a number of things. But that doesn't really happen on the surface of the moon. So these craters form and they're pretty much just there. Alright, so unfortunately, yeah, it's not really getting any better here as our cloud situation goes. So, what? It's 10 o'clock? Oh, it is. Yeah. Alright, well, so we would like to thank you for joining us here for some of the things we were able to see. I'm pretty glad that we were able to see the conjunction there of Venus and Mars even for a little bit, because it wasn't so easy when we tried for Jupiter and Saturn last year. But thank you for joining us here once again.
Have a great evening, everybody. Thank you.
And yes, have a great evening. Thank you.